Okay, good morning, class. So today we're looking at functions. This is the last lesson dealing with functions part 1. Part 2 will deal with determining the equation thereof and then some more interpretation of these graphs. Okay, that is when they give you the graph and you must determine the equation thereof and then do the interpretation, and which we are doing already, but just with them giving the graph. And you'll see how much easier that would be as well. Okay, provided that you understand what's going on here. Alright, so we're doing the last part of the exponential graphs. These are the sums I gave you for homework, correct? Yes. So I'm just going to pull these two down, or these three down. Just look at the first one. Okay. Okay, this is part 5. Please settle down if you don't mind. You are writing tomorrow. For those of you who don't know. Okay, so let's look at the first one. So the shape of this graph, definitely the graph is an increasing function. Not so with the horizontal asymptote of y is equal to -9. Then we work out the x-intercept. What we do? Then y equal to 0. So 0 is equal to 3 to the x minus 9. So get over the equal sign becomes positive 9, which is 3 squared. Therefore x equal to 2. Then our y-intercept, what do you do for y-intercept? X equal to 0. So y is equal to 3 to the 0 minus 9, which is negative 8. So this is enough information to draw this graph. Okay, so there's your 0. Horizontal asymptote at y is equal to -9. So we cut at -8. As you know, the graph is increasing, so it comes close to asymptote. Doesn't touch there, and going through the x equal to 2. You all okay with that? Yes. Okay. Then there was a couple of questions that I gave you with regards to the sum, the main range. So we'll list it and then we'll answer it as well. So just look at the first one was the main range. F of x equal to 0. F of x is less than 0. The graph increasing or decreasing? Determine the new equation of the graph. If f of x shifted 2 units. Anything else? So let's look at the first one. Domain, as you can see, is going negative infinity and positive infinity. So x is an element of real numbers. The range all possible y values. Does this graph exist at negative infinity on your y? No. Which sort is existing at -9 onwards? So you got y -9. It has to be more than. Can it be equal to -9? Why not? It's an asymptote. It doesn't touch. With f of x equal to 0. With f of x equal to 0 is equal to 0 at x equal to 2. With f of x less than 0. So it's where it's below this line of y is equal to 0. So it's this part of the graph here. In other words, x has to be less than 2. Okay. Number 5. Is this graph increasing or decreasing? As we're going from left to right, you can see the graph is increasing. Number 6. Determine the new equation in f of x is shifted 2 units up. So we're just adding 2 onto the equation. So y is equal to 3x minus 9 plus 2. So y is equal to 3x minus. Okay. Right, here's the next one. So you got y is equal to a ninth raised to the x minus 1. So what do we do here? Shift. So we shape. So what do we know about this graph? Decreasing. And it has horizontal asymptote. Y is equal to -1. Secondly, y-intercept. What do you do for y-intercept? Let x equal to 0. So we have y is equal to 1 over 9 raised to 0 minus 1, which gives you 0. Your x-intercept. What do you do for x-intercept? Let y equal to 0. So 0 is equal to 1 over 9 raised to the x minus 1. We take it over the equal sign. So 1 is equal to 1 over 9 raised to the x. But remember, we need to make the bases the same for the exponents to be equated or being equal. Now, 1 can be written as a ninth raised to the power 0 is equal to 1 over 9 raised to the x, which implies that x is equal to 0 there. So if you look at this graph, let's just drop this a bit. If you look at this graph, asymptote we draw in first, so y is equal to -1. It's going to cut 0 there. Now, so we know the graph is going to do that, or it could have done that, or it could have done that, or it could have come lower there, and so on. Okay, so to give a shape, a better shape of this graph, we choose a value for which x can be equal to. Okay, so what do we choose? We say let x equal. So if x equal to 1, we got y is equal to 1 over 9 raised to the 1 minus 1, which is -8 over 9. If I let x1, that is -8 over 9. So it's that point there, 1 and -8 over 9. The graph comes through like that. Nope. I made a mistake some. Oh, it's a decreasing graph. Doing increasing. And there we go. Just change the color there. There is a lot of information on the graph. So there we go. Decreasing function going through that thing. Right, you guys understand? This is key now. We need to generate another point on the graph. We always let x equal to 1. And we generate another point. Wherever needed, we do that. Right, let's look at the questions pertaining this graph quickly. Yes? We can go back to the video later. Okay. Sorry? 1 over 9. This is decreasing function. I don't know if you were in the previous lesson, but we said if it's in the form of y is equal to k to the x plus q. I think I used the b whatever. But if k is greater than 1, the graph was increasing. And if k is less than 1 but greater than 0, the graph was decreasing. Now you see 1 over 9 lies between 0 and 1. So it's a decreasing function. Alright, so let's look at the domain quickly of this graph. Domain. What is the domain? All possible x values, no? So it covers all the values of x, not so? So what do I write? X is an element of all real numbers. Let's look at the range. Does this graph exist at negative infinity? No, where it start existing at? Negative 1 onwards. So in other words, y must be greater than negative 1. Thirdly, which f of x equal to 0? And x is equal to 0. Which f of x less than 0? Is this part of the graph here? Not so. So in other words, x must be, it's going in the positive, so it must be more than 0. X must be more than 0. Next, is this increasing or decreasing? Decreasing. Determine the new equation if f of x shifted 2 units up. So that's going to be that plus 2. So y is equal to 1 over 9 raised to the x plus 1. Okay. Do one more and then we're going to do something different. Yes?
The asymptote is negative over 9. The point.
Negative 8 over 9. Because I need x equal to 1. What is the other equation I gave you to do? Oh yeah. Okay, I'll do both. I see the importance of both. Alright, so let's do this quickly. Firstly, the shape. What can we say about this graph? Increasing graph. We have the horizontal asymptote of y is equal to 9. And you work out a y-intercept. What do you do for y-intercept? It's equal to 0. So you got y is equal to 3 to the 0 plus 9. We give you the answer 10. When you work out our x-intercept, what do you do for x-intercept? Y equal to 0. So 0 is equal to 3 to the x plus 9. But I get over the equal sign becomes negative 9, which is negative 3 squared equal to 3. People, is this basis the same? No. So we can't equate the exponents. Not so? And we can't use that rounding, what do we call that, by inspection, I think it was, we did when we did equations of exponents. So in other words, there's no x-intercept. It's not going to cut your x-axis. For those of you who don't see that, if you're looking at the graph y is equal to 3 raised to the exponent x, and I drew this graph, we go minus 1, 0, and 1. Minus 1 gives you a third, a 0 gives you 1, and 1 gives you 3. Can you see here? Does this graph cut the x-axis? No. So what effect does plus 9 have on the graph? So we shift the graph 9 units up. Which means to say the asymptote also moves 9 units up. So with this graph that's here at y is equal to 9, with this graph, ever cut the x-axis? No. And clearly there's no x-intercept. So what did I say earlier on? If we need to generate another point on the graph, what do? We let x equal to 1. So we have y is equal to 3 to the 1 plus 9, which is 12. So the point is 1 and 12. Y, x Drawing our asymptote first of y is equal to 9. This is by approximation. I don't have to throw it right on top of the graph. So the graph is increasing. He has a y-intercept at 10. And if x is 1, y is 12. Coming close to the asymptote but doesn't touch, and there's the graph. Okay. Any confusion there? Any questions? Sorry? Any confusion? No. Okay. Okay, so let's look at the questions pertaining to these graphs. Interpretation of these graphs. First one, domain. What's my domain here? X is an element or real numbers here. X is an element of all real numbers. Range. Y must be greater than 9, yes. Next. Is f of x equal to 0? No way. Not so. Not so. So we write no solution. Next. Is f of x less than 0? Is there any part of the graph which is less than 0? No. So what do we write? No solution. Is the graph increasing or decreasing? Increasing. Determine the new equation if f of x shifted 2 units up. So y is equal to 3x plus. Did you guys understand, people? It's fairly simple. One more. Alright, so where do we start here? Shape. This graph is decreasing. There's horizontal asymptote of y is equal to 1. Secondly, x-intercept. What do you do for x-intercept? Y equal to 0. So 0 is equal to 1 over 9 raised to the x plus 1. To get over the equal sign, so it's 1 over 9 raised to x equal to negative 1. There's no way I can write that as a base of 1 over 9. Not so. So what does that mean? No x-intercept, or no solution. Then we write y-intercept. What do you do for y-intercept? X equal to 0. So y is equal to 1 over 9 raised to 0 plus 1, which is 2. So if I draw this graph, first thing we're drawing is the asymptote of y is equal to 1. Got your y-intercept at 2. So we need to generate another point on this graph, not so? So how do I generate another point? Let x equal to 1. So we got y is equal to 1 over 9 raised to 1 plus 1, which is 1 and 1 over 9. Now is 1 and 1 over 9 above or below the asymptote? Here's 1. How can 1 over 9 be below? Must be above. So if x is 1, y is 1 over 9, 1 and 1 over 9. So as you can see, the decreasing graph, so the graph is doing that. Okay. Okay, so let's look at the questions pertaining to the graph quickly. If you feel that at any point we're moving too fast, you can just pause the video. But at this point, the student has done this already for homework. I should have done. Right, so let's look at the first question. The first one is the domain. What do we do for domain? All possible? X value. Negative infinity and positive infinity. So X is an element of range. Y values. So Y must be greater than 1. With f of x equal to 0. No solution. With f of x less than 0. No way. So no solution. Is this an increasing or decreasing graph? Decreasing. What happens if you shift this graph 2 units up? It becomes y is equal to 1 over 9 raised to x plus. You see, the more you do the graph, the easier it will become. Okay. So this is one graph I still need to do with you guys with the exponential function. Okay, that is where the negative is in front of it. Okay. So you got y is equal to negative 3 times 2 to the x plus 6. So if you take this graph into account, if you got y is equal to 2 to the x, is that an increasing or decreasing function? Increasing function. There's a horizontal asymptote of what? Y is equal to 0x. So it's an increasing function of y is equal to 0, and this of course is 1. Okay, and if that is 1, this should be 2. Okay. You all okay with it, no? Okay. What's happening here? You don't know, you never did the exponential graph. Did you miss a lesson? Yes? Now whose fault is that? With this graph? This one? Which one? This here? No, I'm showing you something here. Is it okay if I show you something first? Who's the kilo? Example. I'm just showing you an example here. I'm telling you from some point you should have been familiar with. You should have been familiar with it. Not so. Right. So, if I take this graph, as you can see, it's increasing here. And I have to put a negative in front of that too. If we have a graph looking like this, y is equal to negative 2 raised to the x. Not so. So if I put that graph into the calculator, go both table 7. Let's go from minus negative 2 raised to exponent x. Right now, g of x, you're going to start at negative 2, and we're going to end at 2, and we're going to go in steps of 1. So you see how what happens is if I go with this graph here, negative 2, there's negative 1, negative 2, 1 and 2. Okay. If I substitute negative 2 and I get a quarter, negative a quarter, negative half, when it's negative 1, 0 is negative 1, 1 is negative 2, and 2 is negative 4. So what do you notice now about the two graphs? It's actually a reflection of the graph, of the black graph, in the line y is equal to 0 over the x-axis. Can you see that, people? So let's just draw that a bit clearer. That is the first graph. This is the 2x graph. Not so. If I draw the other one, it looks like that. Y is equal to negative 2 to x. Can you see that, people? What don't you see? Do you know how I draw the graph in black? Alright. So that graph in black would be have been drawn using a table. Not so. I'm moving too fast to you here. No? Let's go again. If we take the graph, we're coming back to this graph now. No, we're not here yet. I'm just taking that 2 to the x out and I'm showing you what's happening there. Okay. So if I take a table and I draw the graph for 2 to the x and y, minus 1, 0 and 1, gives me a half, 1 and 2. Are you okay with it? So, if x is negative 1, x is negative 1, y is half. If x is 0, y is 1. If x is 1, y is 2. So this is that graph of 2 to the x. Okay. So now I'm going to use I'm going to draw this graph now. Okay, it has nothing to do with the graph for now in black. Okay. So now I use the same values. So for negative 1 in here, I get negative half, negative 1, and negative 2. You all agree with that? So 1 is negative 1 is half, 0 is negative 1, and 1 is negative 2. So what do you notice? This is the graph of y is equal to minus 2 things. Now in comparison to the graph in black, what do you notice? The same shape, but it's reflected in the x-axis, or the y is equal to 0. Can you see that? Do you all see that? Do you understand that?
So you must always use the value of negative 1, 0, and 1.
If you want, you could. It will work all the time. Because I say you didn't know how to draw this graph. Let's go with this one here. No? And I say, okay, we're drawing the graph y is equal to 3 to the x plus 9. X and y. So negative 1 gives you 9 in a third, gives you 12 in a 10, and gives you 12. Remember that you asymptoted y is equal to 9. X is negative 1, 0 and 1. That is going to give you 9 and a third. X is 0, y is 10. X is 1, y is 12. There is that graph exactly. Which is that graph. Can you see? So if you wanted, you could. Okay? Just coming back to this here, that what do you notice about the two graphs? We see that is reflected in the x-axis. But if you compare the two equations, what do you notice? It's a negative in front of the function. Not so. So that's now a rule for us. Okay. So you write this rule down. Reflected. But we're going to do a little if something is reflected in the x-axis, y becomes negative. Because if you also do the comparison here, you see it reflected in the x-axis. X remains the same, but what happens to y? Becomes negative. Can you see that? That is 0 and 1 becomes 0 and negative 1. Can you see that? This was 1 and a half became 1 and minus half. So if it is reflected in the x-axis, y becomes negative. But we're going to do another investigation on that after you write. Okay. So this is something you must note at this point. Reflected in the x-axis, y becomes negative. And if something is reflected in the y-axis, what do you think is going to happen? Huh? If I reflect something in this line, If I take this point and I reflect it here, then this would be positive 1 and a half there. Not so. If this is 1 and 2 and I reflect it here, it becomes negative 1 and 2. So what do you notice? X becomes negative. So the rule is you reflect it in the x-axis, y becomes negative. Something reflected in the y-axis, x becomes negative. Okay. Two golden rules I need you guys to write down. Very important. Okay. Well, sounds like you guys are finished. So now you can ask yourself, okay, now how does this fit into what we are currently with the equation at hand? Okay. Just coming back to this now. Right, so the question is to draw the graph y is equal to negative 3 times 2 to the x plus 6. Can that become negative x and negative 6 to the x plus 6? Can I multiply those two numbers then? Can I multiply, pull your face like that? Can I multiply these two numbers and say negative 6 to the x plus 6? No. Why not? Yes, because of the exponent there. Okay. Because of the exponent, we can't do that. So, when we start with the shape of this graph. So, considering that, what can we say? Increasing or decreasing? It's increasing. Not so. But because of this negative, it's going to be reflected into the, yes? What do you call that? The x-axis here. Can you see that, people? So in other words, this graph is actually going to do that, as I just showed you now from the previous explanation. Can you see that, people? Let's go again. You see this here? That b value is greater than 1. So the graph is increasing. But because of this negative here, it will be reflected in the x-axis. The graph would be now decreasing. Okay? If the graph had to be decreasing and I reflect it in the x-axis, what's going to happen? It will be increasing. You guys understand? Okay. So that's number 1. And it has a horizontal asymptote that y is equal to 6. This is the reason of this, yeah? Okay. Why? Because of 6? Because of that there. Yes, Michael? I just showed you now that if this is negative here, it's going to reflect in the x-axis. And that is why it's going down. Okay? You see, because that earlier on was, if you add only this, then the graph is increasing. When I put a negative in front of this, what happened earlier on? So it's reflected in the x-axis. So y becomes negative. Decreasing function. Okay. What do we do thereafter? Y-intercept. What do you do for y-intercept? X equal to 0. So y is equal to negative 3 times 2 to the 0 plus 6. So that will give you an answer of 3. So you got x-intercept. What do you do for x-intercept? Let y equal to 0. Okay? So you got 0 is equal to negative 3 times 2 to the x minus plus 6. So you get over the equal sign. So 3 times 2 to the x is equal to 6. Divided by 3 both sides. So 2 to the x is equal to 2 to the x is equal to 2. So I'm dividing 3 both sides. Therefore, x is equal to? So you got the x-intercept, you got your y-intercept. So it's enough information to draw this graph. Okay. Okay, so we start off by writing in the asymptote of y is equal to 60. So your y-intercept is at 3 and 1. So as you can see, it's going to come close to this asymptote but doesn't touch. And there we go. Okay, we'll do another one like it now. I'll give you a chance to do the next one. But let's first look at the questions pertaining to this graph. Okay. Don't blow so. It's already so hot in here. The weekend too long. Right. First things first, the question says domain. How do you calculate this domain? Domain is all possible x values. So what's my domain here? X is an element or real numbers. Range. Does this graph exist at negative infinity? Yes. So where does this graph stop existing at? 6. Is anything less than that? So in other words, y must be less than 6. Next, where is f of x equal to 0? At 1. Where is f of x less than 0? So it's in other words, where it's below this y is equal to 0 line with the x-axis. Not so. So it's this part of the graph. So in other words, x must be more than. Is this an increasing or decreasing graph? As x increases, this graph is decreasing. It's a decreasing function. Can you see that? So it's decreasing. What will happen if I shove this graph to and it's up? Y is equal to negative 3 times 2 to the x plus. Okay. So let's give you a chance quickly to do this graph. Like go. If not, why not? So we got y is equal to 2 times 3 to the negative x. Is a negative there? Plus 18. There's the next graph I want you guys to do. Okay? So I'll put it down. I'll pause the video at this point as well. Alright, here we go. When we stopped, we start off with the shape of this graph. So 3 to the minus x is the same as y is equal to a third to the x. Not so. Now is that increasing or decreasing? Decreasing. But if it's reflected in the x-axis, then the graph would be increasing. So this is the shape of the graph I need to do. Not so. And you have a horizontal asymptote that y is equal to 18. So what do we do here after? X-intercept. Let y equal to 0. So we got 0 is equal to negative 2 times 3 to the minus x plus 18. We get over the equal sign, so 2 times 3 to the negative x is equal to 18 divided by 2. 3 to the minus x equal to 9. And 9 can be written as 3 squared. Therefore, minus x is equal to 2. X is? Okay. This is a long way. But you got the same answer. You get the right. What do you do thereafter? Y-intercept. What do you do for y-intercept? 0. So you got y is equal to negative 2 times 3 to the negative 0 plus 18. It's going to give you 16. You guys understand? So let's go. So your y, x, origin. So the first thing we draw in? Asymptote. At y is equal to 18. Now mind's eye, the graph is an increasing function. It cuts your x-axis at negative 2 and your y-axis at 16. So as you can see there, the graph is an increasing function. Okay. Easy. You all okay with that? Right, so let's answer the questions quickly pertaining this graph. For this graph. Number 1. Domain. What's the domain of this graph?
X values.
All possible x values. So x is an element of R. X is not equal to? No. It's all the values. Even negative 2, it can't be a negative. Hereafter, range. Range is all possible? Y values. Does graph exist at negative infinity? Yes. Where does stop existing at? 18. So y must be less than 18. Thirdly, where is f of x equal to 0? Negative 2. Fourthly, where is f of x less than 0? Is this part of the graph not so? In other words, x must be less than negative 2. Is it an increasing or decreasing function? Increasing. As x increases, the y is increasing. Determine the equation if this graph of 2 is up. So y is equal to negative 2 times 3 to the x plus 20. Right, you guys understand?
Yes.
Right. So that brings us to the end of the part 1 of your functions. And you are writing up until here for tomorrow. Okay. Let's stop the video at this point.